Hello everyone, today we're going to talk about the 10,000 meter deep sea, a place far harder to reach than outer space on Earth. When people think about exploring the unknown, the vast universe always comes to mind first. The Moon, Mars, distant galaxies, countless space probes break through the atmosphere to travel among the stars. Manned moon landings and long-term space station stays have become feats humanity can achieve. But do you know something? The Mariana Trench, merely 10,000 meters beneath our feet, a restricted deep sea zone covering 70% of our planet's surface, is vastly more difficult to access than outer space. Outer space only brings vacuum and extreme cold, with no crushing force capable of destroying human machinery. The seabed 10,000 meters down bears terrifying water pressure of Fe megapascals, equal to Fe standard atmospheres. This force can easily crush regular nuclear submarines and tear apart most metal equipment built by humans. 12 people have set foot on the Moon, yet fewer than 20 humans in total have personally reached the bottom of the 10,000 meter trench. Countless devices are deployed for space exploration, while only a handful of manned submersibles worldwide can steadily dive to 10,000 meter depths. Nature has erected an invisible cage of frigid seawater, sealing off the entire abyss and blocking all outside prying eyes. Almost all ocean footage we see in documentaries and short videos is limited to the sunlit layer within 200 meters of the surface. Sunlight penetrates the water, algae thrive, and schools of fish swim freely, yet this is merely an insignificant outer shell of the ocean. But when scientists scan the entire ocean with deep-sea sonar and unmanned submersibles, the footage transmitted back completely overturns everyone's inherent understanding of the ocean. You might naturally assume that as depth increases, the seawater grows more barren, leaving nothing but empty silt in the end. The truth is the exact opposite. Strange fish capable of self-illumination populate the pitch, black waters thousands of meters deep. Complete communities of living creatures survive on underground chemical substances in the silt at the very bottom of the 10,000 meter trench. Life never fully vanishes in this extreme wasteland of perpetual darkness. Bone, chilling cold, scarce food, and pressure strong enough to crush steel. Today we will follow our vision, starting from 0 meters at sea level, descending vertically all the way to Fe meters at the bottom of the Mariana Trench. We will unlock the secrets hidden at each depth of the deep sea layer by layer, and reveal what bizarre creatures defying the rules of life lie hidden. In this abyss, more mysterious than outer space, you may ask, what exactly does Fe atmospheres feel like? Is it truly that terrifying? The principle behind it is easy to grasp. We live on land, constantly under one standard atmosphere of pressure, perfectly balanced inside and out, so we feel no discomfort at all. Every 10 meters you dive underwater adds one more atmosphere of external pressure. At 100 meters, 10 times atmospheric pressure can trigger severe decompression sickness in regular divers. At 1,000 meters, 100 times atmospheric pressure warps ordinary steel containers. Once you hit 10,000 meters, Fe times normal pressure envelops all objects from every direction. Try to picture this scene. 500 fully loaded heavy trucks stacked one on top of another, their full weight pressing down on your body all at once. That is the environment present every single moment 10,000 meters under the sea. Hard materials besides steel and rock will twist and shatter rapidly under these conditions. Glass, plastic, and common alloys made by humans cannot withstand this extreme environment for more than half an hour. Nature has forged a natural barrier from seawater, locking the abyss tight and stopping humans from easily glimpsing its true interior. For a long time, humanity clung to a fixed belief: all life relies on sunlight to survive. The foundation of every ecosystem on the surface comes entirely from photosynthesis carried out by plants with sunlight. Without sunlight, there are no primary producers, and the entire food chain collapses instantly. Yet starting 1,000 meters below the sea surface, sunlight vanishes completely in the 10,000 meter deep sea, plunging the entire water body into endless darkness forever. No light means no algae means no tiny plankton, and the survival logic of the surface ocean completely fails here. Can any life truly thrive and reproduce steadily in this pitch, black wasteland with steel, crushing pressure, and almost no food to spare? With this ultimate question in mind, our deep sea dive officially begins our descent from sea level at 0 meters. Our vision passes through the glistening sea surface, sinking slowly to 200 meters, 500 meters, 800 meters, until we reach the twilight zone's end at 1,000 meters. Once we stabilize at 1,000 meters, sunlight is cut off entirely, and the seawater is wrapped in pure darkness. The first creatures we encounter are not giant deep-sea leviathans, but swarms of tiny strange creatures carrying their own light sources. Do not underestimate these glowing marine creatures drifting through the dark. Their evolved survival mechanisms break all the survival logic of shallow water sea life. You might think that glowing in pitch black water only exposes them, making them easier prey for predators. If you believe that, you underestimate the survival wisdom forged by millions of years of evolution in deep-sea creatures. In total darkness, bioluminescence is not a weakness, but a core weapon they depend on to stay alive. First, we see stretches of floating jellyfish, translucent all over, lined with tiny luminous glands along their edges. As they drift, they emit soft pale blue halos like floating stars in the black seawater. This blue light serves two critical purposes. First, it confuses large predators chasing them. Sudden bright light blinds hunters momentarily, buying the jellyfish time to escape. Second, it lures tiny plankton close to be used as food. Right after the jellyfish appear, we spot the menacing gulper eel with a disproportionately massive mouth whose lower jaw can expand without limit. This fish has no rigid regular ribs, its body soft as rubber, and its stomach can stretch dozens of times larger to swallow prey far bigger than itself. The gulper eel's tail holds a luminous organ that glows faint red non-stop, acting as bait in the dark to lure unsuspecting small fish within reach before swallowing them whole in one bite. We also spot the slender, flat hatchetfish with bulging upward, facing eyes and neat glowing stripes running down its sides. The light glands along its underbelly adjust brightness to match faint residual light seeping down from above, perfectly erasing its silhouette. Shallow water fish rely on body color to hide from predators, while hatchetfish use self-generated light to camouflage themselves, vanishing visually into the seawater entirely. These creatures living at 1,000 meters are merely entry, level inhabitants of the abyss ecosystem. Extremely faint organic debris still drifts down from the surface here. Dead fish, shrimp, and algae fragments slowly sink to this depth, barely sustaining small creatures. But as we keep descending past 3,000 meters, the volume of falling food waste plummets, and competition for survival grows far crueler. Creatures here are generally smaller, having evolved far more extreme hunting tactics, each species bearing unique structures that defy common sense. This is only the appetizer of our deep-sea exploration, however. Our real target is the Hadal zone below 6,000 meters, the true no man's land for life. We continue drifting downward, passing 4,000 meters, 5,000 meters, before finally halting at 6,000 meters, officially entering the Hadal Sea. The instant we step into this zone, everyone shares the same question. Ordinary creatures would be crushed instantly under this water pressure. So why can the fish and shrimp here remain intact? The freshwater and marine fish we interact with daily hold countless hollow spaces inside their bodies, swim bladders, bones, gaps between internal organs. These cavities collapse under 10,000 meter pressure, twisting and destroying their entire bodies in an instant. Yet after millions of years of evolution, fish in the Hadal zone have abandoned all hollow structures entirely. They possess no swim bladders, thin, pliable bones, and cells filled with high concentration pressure, resistant organic matter that balances the crushing external water pressure. Thousands of times atmospheric pressure pushes inward from all sides, while fluid inside cells pushes outward to counteract it, balancing pressure evenly so their bodies suffer no damage whatsoever. The blobfish stands as the most iconic example, dwelling on trench slopes between 6,000 and 8,000 meters deep. It has no hard scales or sharp bones, its whole body made of gel, like soft flesh slightly denser than seawater, letting it float effortlessly without wasting energy. When blobfish are brought up to low-pressure shallow waters, their internal balance collapses, their bodies rapidly inflate and sag, creating the ugly shape widely circulated online. Within their native deep-sea habitat, however, their body structure fits the high-pressure environment perfectly, moving steadily to feed on tiny invertebrates in the silt. Even more mind-bending than the blobfish is the unique reproductive cycle of deep-sea anglerfish, the most unusual symbiotic survival pattern across the entire ocean. In regular fish we see, the size gap between males and females is never extreme, but anglerfish break this rule completely. Female anglerfish can grow over 1/2 meter long with a rod extending from their heads topped with a glowing orb to lure prey. Fully grown male anglerfish measure only a few centimeters long, with no hunting organs or luminous devices. They cannot source food on their own to survive. A male anglerfish's sole purpose after hatching is to search for a female across the endless dark. Once it finds a target, the male sinks its teeth deep into the female's abdomen. its mouth tissue fusing permanently with her skin, their blood vessels interconnecting. From that moment onward, all the male's organs gradually atrophy, leaving only its reproductive system intact, sustained by nutrients flowing from the female's bloodstream for its entire life. A single female anglerfish can host over a dozen parasitic males on her body, ready to reproduce at any time. This body-parasitic bond between male and female has no equivalent in any surface ecosystem, a unique evolutionary outcome spawned by the deep sea's extreme conditions. The 6,000-meter zone is already harsh enough, yet we still have thousands of meters left to sink before reaching the trench bottom at 10,000 meters. The deeper we travel, the colder the seawater drops, holding a constant 1 to 2 degrees Celsius, icy to the bone. Food sediment all but vanishes, and only occasional carcasses of large animals falling from the surface can temporarily feed creatures across this zone. The slow descent of dead whales into the deep sea is known as whale fall. A single large whale carcass can sustain all kinds of deep-sea creatures for 100 years. Whale remains drift slowly from the surface to the 10,000-meter trench floor, consumed by creatures at every depth along the way, their muscle, organs, and bones broken down one after another. Once the debris finally settles on the 10,000-meter silt, anaerobic bacteria continuously break down lipids inside the bones, feeding masses of microorganisms and forming a complete miniature ecosystem. The phrase "one whale fall nourishes all life" holds its most tangible meaning within the 10,000-meter deep sea. Whale falls are extremely rare resources that occur only once every few decades. However, most of the time, the 10,000-meter trench floor receives zero organic material from the upper ocean. Many people therefore insist no life can exist at the 10,000-meter trench bottom. Yet footage captured by deep-sea submersibles completely overturns this conclusion. We keep diving past 8,000 meters, 9,000 meters, until we reach Fei meters, Challenger Deep, the lowest point of the Mariana Trench. No fish are visible as far as the eye can see, the entire region covered in thick gray deep-sea silt. Beneath that silt lies the most staggering life system of the entire abyss. Scientists collect silt samples to bring back to labs for observation, revealing massive colonies of microorganisms packed into every inch of sediment under microscopes. These microorganisms need no sunlight, no plant or animal debris falling from upper ocean layers, surviving solely on chemical substances seeping from rock fissures underground. Tectonic activity along the trench's subduction zone persists non-stop, with underground cracks constantly releasing low-temperature fluid rich in hydrogen sulfide, methane, and minerals. These chemical compounds serve as the sole energy source for abyss microorganisms, which carry out chemosynthesis to break down inorganic matter for nutrients and multiply. This follows a completely separate survival path from surface plants, relying on photosynthesis powered by sunlight, rewriting humanity's fixed definition of the conditions required for life to exist. Supported by these microorganisms, tiny amphipods, polychaete worms, and deep-sea crustaceans multiply within the silt, forming a fully closed loop ecosystem entirely independent of solar energy. Cut off from sunlight and surface organic supply forever, this ecosystem still cycles steadily and endures for millions of years. If you pause to work through the logic, you will grasp how astounding this truly is. When humanity searches for extraterrestrial life, we long assumed habitable planets must have starlight, liquid water, and mild temperatures. Yet life thriving at the bottom of the 10,000-meter trench proves life can survive entirely without sunlight, sustained by geochemical energy originating within a planet itself. Beneath the ice crusts of Europa and Enceladus in the solar system stretch vast liquid oceans with underwater geothermal vents, environments highly similar to the Mariana Trench. If the 10,000-meter deep sea on Earth can evolve chemosynthetic ecosystems, subsurface oceans on distant alien planets stand a good chance of nurturing unknown life as well. Tiny microorganisms in the 10,000-meter abyss offer humanity tangible, real-world reference samples for our search for extraterrestrial life. Many people raise a new question: if complete ecosystems exist at the 10,000-meter trench bottom, could giant unknown sea monsters never discovered by humans dwell there based on all existing scientific detection data? The 10,000-meter deep sea cannot support large creatures long-term. Giant organisms require massive volumes of food to sustain their bodies. Yet food resources are extremely scarce at the trench bottom, limited to microorganisms and tiny invertebrates, with no capacity to feed large animals. Most bigger deep-sea creatures live in midwater zones between 1,000 and 4,000 meters, surviving on food debris falling from above and never descending to the extreme 10,000-meter depths. This does not mean the 10,000-meter abyss holds no brand. New species unrecorded by humanity, however. Every deep dive expedition leads researchers to discover multiple brand, new miniature creatures, tiny beings dwelling in silt gaps and rock fissures that detection equipment struggles to capture. Humanity has completed fewer than 100 dives to 10,000-meter depths, and less than 5% of the entire Mariana Trench has been surveyed. This zone, harder to reach than outer space, holds over 90% of its territory never closely observed by humans, countless unknown species hiding beneath the dark silt waiting for exploration. Beyond bizarre life systems, the 10,000-meter deep sea bears indelible traces left by humanity that fill us with sorrow. On multiple deep dive missions, submersible cameras captured plastic bags, discarded fishing nets, plastic bottles, metal waste, and even disposable masks. Marine garbage discarded by humans drifts slowly with ocean currents, taking years to settle at the absolute bottom of the 10,000-meter trench and deposit within the silt. Far removed from human residential areas, no garbage is intentionally dumped here, yet the 10,000-meter deep sea cannot escape erosion from plastic pollution all the same. Plastic cannot be decomposed by deep-sea microorganisms, remaining trapped within silt permanently and seeping into the entire abyss food chain. Tiny creatures ingest plastic fragments, toxic substances passing up the food chain tier by tier, ultimately impacting the entire Hadal ecosystem. We always imagine the remote deep sea as a pure land isolated from human activity, yet pollution generated by humans has seeped into every corner of the planet. Even the 10,000-meter abyss crushed under Faye atmospheres cannot escape its reach. After covering the deep sea's life, environment, and human leftover traces, we can clearly see the massive gap in exploration difficulty when comparing deep-sea expeditions to space travel. Manned spacecraft breaking through the atmosphere only need to withstand vacuum and extreme temperature swings, their hulls under no constant inward crushing pressure. With proper sealing and thermal insulation, they can remain in space steadily for months or even years. Manned submersibles diving to 10,000 meters must resist thousands of times atmospheric pressure squeezing inward non-stop, every welded seam and viewing window on the cabin built to withstand extreme compression perfectly. Every 10,000-meter dive carries significant risk. The tiniest flaw in equipment can trigger catastrophic failure under deep-sea pressure. Numerous deep-sea detection craft have suffered hull deformation and cracked viewing windows during descent, abandoned forever thousands of meters below the waves. To complete a short observation mission at 10,000 meters, research teams spend months calibrating equipment, pour enormous sums of money, and bear unforeseeable risks the entire time. By contrast, space observation satellites and probes can operate remotely for long stretches continuously, with far lower costs and risks than deep-sea exploration. Humanity crossed 380,000 kilometers to land on the moon, yet cannot regularly reach the trench floor 10,000 meters beneath our own feet. The vast universe lies billions of light years away. Yet it is easier for humans to observe and explore. The 10,000-meter deep sea sits right beside us, separated only by a thin layer of seawater, yet it stands as the hardest to access secret territory on Earth. This stark contrast forces everyone to re-examine the ocean beneath our feet. Ocean covers 70% of Earth's surface, yet humanity has fully explored less than 5% of it. We pour massive resources gazing up at the stars, yet we often overlook this dark blue abyss wrapping our planet and holding countless secrets of life. The 10,000-meter deep sea overturned the fixed belief that all life requires sunlight to survive, evolving countless bizarre creatures whose forms and survival patterns defy all common sense. Chemical energy surging from rock fissures sustains independent ecosystems, opening entirely new lines of thought for humanity's search for extraterrestrial life. Thick seawater blocks outside interference, preserving unique evolutionary trajectories intact for millions of years, like a giant natural laboratory sealed away by nature. Yet humanity's exploration has barely scratched the surface of this abyss. Countless unknown creatures lie hidden in dark silt, unnamed and unseen. Underground hydrothermal vents, rock fissures, and ancient fossil remains rest deep within the trench, waiting for scientists to lift their veil. As deep diving technology upgrades continuously, more manned submersibles will travel to the 10,000-meter trench in the future, unlocking hidden deep sea secrets non-stop. Perhaps in the near future, we will discover more new life forms at Challenger Deep that overturn existing theories of biology. Perhaps we will piece together the full evolutionary timeline of the very first life on Earth from deep-sea microorganisms. Perhaps the unique pressure, resistant cell structures of deep-sea creatures will provide new directions for human research into new materials and medical technology. This 10,000-meter abyss, harder to reach than outer space, is never a desolate cage of seawater devoid of life. It is the most precious treasure trove of unknown knowledge left to humanity by Earth, holding all the answers that can reshape our understanding of life, geology, and space exploration. Vast stretches of pitch, black deep sea still lie unseen by human eyes to this day. How many unimaginable unknown worlds remain hidden within the perpetual darkness, crushed under Time's atmospheric pressure? This question can only be answered piece by explorers who keep venturing deeper into the sea in the years to come.